Now this illustration deals with phase arrangement in accordance with 408.3 E is in Ed and F is in Fun. Now this figure deals with requirements concerning the high leg. Now we really went over this in detail if you had the opportunity to review Chapter 6 of Stallcup's electrical design book. But now notice in the note, the main section is 110.15. But if this closed delta system is supplying the service, then we have to look at 230.56 to obtain the rules. But notice the high leg has to be orange in color or some identification that is approved by the authority having jurisdiction. So as you notice now, we called this out before. Notice in the illustration the orange colored insulation. It terminates to B, that conductor. It goes through a 240 volt winding, through a 120 volt winding to ground. So B travels through 240 to A, and from A down to half of the winding A and C, and connects to the center of that winding is a common connection, and we obtain 120 volts to ground. But notice the high leg is 208 volts to ground and cannot be used to supply 120 volt related type equipment. But we can supply three-phase equipment with 240 volt phase to phase, as you see in the drawing. So we could have a closed delta system, as you see, or as in Chapter 6 where we reviewed the open delta type connection. But now method 1, we could derive the high leg by taking phase A plus phase B and dividing it by the square root of 3, which you know well is 1.732, and we would come up with the 208 volt high leg. Or you could take 120 volt and multiply by the square root of 3, and you'd come up with 208 volt. So what this is pointing out, if the grounded conductor or neutral is present in the system, then the high leg would connect to phase B or L2 in the switch, panel board, or wherever that termination is made. But the rules of the phase arrangement is fully illustrated and talked about in NEC 408.3 E and F, and that's what figure 7-3 is illustrating.